I know you've been waiting for this all day. It's a proof in coordinate geometry. So this is the midpoint connector theorem. It's got two parts to it. So the theorem is in italics there. The segment connecting the midpoints of two sides of a triangle is parallel to and half the length of the third side. So in this case, the third side is AC. So what we're going to do is we're going to prove both parts. So I put the triangle on a graph with A at 0, 0. So let's just identify our points here. And then C, so this is at 8, 2. And then point B is at 4, 5, it looks like. Then point D is at 2, 2 something, 2, 2.5. Well, we got to find that. We can do that in a minute. All right, so first step, prove that DE is parallel to AC by finding the slopes of the respective line segments. All right, so looking at AC, the slope is y2 minus y1 over x2 minus x1. So 2 minus 0 over 8 minus 0, which is a quarter. Okay. So for DE, it looks like E, well, it's at the midpoint. To find the midpoint, you just average the X's and Y's. So you go 8 plus 4 is 12, divided by 2 is 6. So the X coordinate is 6. And then the Y coordinate, 5 plus 2 is 7, over 2 is 3.5. So this should be at 6, 3.5. And sure. Then point D is the midpoint of AB. So 4 plus 0 is 4 over 2 is 2. So X coordinate of 2. And then Y coordinate, 5 plus 0 is 5 over 2 is 2.5. So we're at 2, 2.5. All right, now we find the slope of DE. So same formula. So we have 3.5 minus 2.5 over 6 minus 2, and that's also a quarter. So we know they're parallel. So this way back in, maybe it was chapter 3, we looked at the parallel lines and slopes theorem, which is a biconditional. So if two lines have the same slope, they must be parallel. If two lines are parallel, they must have the same slope. So we know that they're parallel here. So we're not doing this like a proof necessarily. I guess we could. So we would say you know, we are given triangle ABC where D is the midpoint of AB and E is the midpoint of BC. And then, we found their slopes. So we'll just say we found the slope of AC is a quarter, and the slope of DE is also a quarter. Therefore, by the parallel lines and slopes theorem, DE is parallel to AC. Sorry, parallel. All right, so that's the first part. Now for the second, it says use the distance formula to show that half of AC equals DE, because the other half is to show that the segment is half the length of the third side. I should have put right here, sorry, out of practice. We should have put right here, we will show DE is parallel to AC and half of AC equals DE. So sorry about that. All right, so for this part, we're going to use the distance formula. So we'll find the distance from A to C. So distance from A to C is equal to the square root of 8 minus 0 squared plus 2 minus 0 squared. So distance is equal, so 8 minus 0 is 8, 8 squared 64. And then 2 squared is 4. So D is the square root of 68. And so this is for AC. And then for DE, distance from D to E, we get the square root of 6 minus 2 squared plus, I ran myself out of room, 3.5 minus 2.5 squared. Sorry about that, that was really silly of me. So 6 minus 2 is 4, 4 squared 16, and then 3.5 minus 2.5 is 1, 1 squared is 1. So D is the square root of 17. Now what's supposed to be true is 1/2 of the square root of 68 is supposed to equal the square root of 17. Now if you can do that on your calculator, and you'll find it's true. However, like, how could you show that algebraically, like not using a calculator? Well, one way to do that is to say the square root of what is 1/2. The square root of what is 1/2. And you find that the square root of a quarter is actually equal to 1/2, right? Because 1/2 times 1/2 is a quarter. So you can substitute here. So you can get the square root of a quarter times the square root of 68 is the square root of 17. Now you're like, why would you do that? Well, when you multiply two numbers under square root signs, you can combine. So you can get the square root of a quarter times 68 is the square root of 17. So now you can do, what is a quarter of 68? Well, that's 17. So now we have the square root of 17 is the square root of 17. So we showed it algebraically, which is better than using a calculator. So then the next part of the proof, using the distance formula. DE equals the square root of 17, and AC equals the square root of 68. Since 1/2 of the square root of 68 equals the square root of 17, we have shown half of AC is DE. All right, and that's the proof. That's the proof. So we use the distance formula, we use the midpoint formula to find the midpoint of the line, and we use the parallel slopes and parallel slope and lines and slopes theorem to prove the two lines were parallel. Again, if you have any questions, email me. Otherwise, here's your homework. And I haven't heard any questions on the homework, so I'm just assuming things are going okay. But if they're not going okay, you should let me know.